Dave, Bill, I don't want to take any more of your time, so please help us out understanding how to enable telco-grade agentic AI over Snowflake AI Data Cloud. That's all yours, and if there's any questions, I'll keep an eye on them. Otherwise, just focus on what you're doing, and I'll talk to you as we go. Thanks a lot.
Thank you, Graham. Hey, everybody. It's great to be back with you here at another IWPC webinar. I am Dave Dugal, founder and CEO of EnterpriseWeb, and I'm joined by my colleague, Bill Malik, our Chief System Architect. We're going to do a presentation today on enabling telco-grade agentic AI over Snowflake AI Data Cloud. And this is actually a recap of the demonstrations that we were doing at MWC 26 just a few weeks ago. It seems like months ago, but it was its life's been a blur. But it was only beginning of March when we were in Barcelona and presenting with Snowflake, our friends Sridhar Rao, the global CTO for Telecom, and Joji Philip, the head of go-to-market for Telecom at Snowflake. And we were up and down the halls of, the FIRA and MWC. But of course, at MWC, everybody's running around like with their chickens, with their heads cut off. So you don't get an hour like this webinar to methodically present an end-to-end demonstration like we're going to do today. So I'm actually very excited about this. We had some great interactions. One of the things that was really interesting is that the buzzwords, it's interesting that every MWC has its set of buzzwords that are the buzzwords of the year. And this year, it was absolutely 100% context and ontology. Now, that's really interesting because I've been bringing up those words in the telecom community since we ran Etsy NFV proof of concept number 1 in 2013. In 2000, so allow me to pat myself on the back a little bit, but we were presenting graph-based, event-driven, policy-controlled, closed-loop automation using agents in 2013. And at that time, people thought we were from outer space. But now I think we're at exactly the right place at the right time. So what we're going to do is we're going to go through our presentation of the collaboration, really joint solution that we're building with Snowflake and what they call their AI data cloud, which is their data warehouses. They have their own language model, Cortex. They have their own analytics and intelligence offerings. They have these things called semantic services. So Snowflake has a rich set of data services. And EnterpriseWeb, we're providing an AI-powered no-code platform. And when you think about when you bring those two together, it's sort of naturally unleashing the value of network data in Snowflake, right? So you've got all this great aggregated data sitting there, and it's ripe for analytics and AI, but it itself just obviously doesn't do execution, it doesn't do automation, it doesn't do behavior. So EnterpriseWeb is partnered with Snowflake to leverage their deep customer base and their deep data sets to do next generation contextual, I would say real-time telco-grade contextual automation. So how we do that is EnterpriseWeb deploys our platform into Snowflake, as we're going to depict on this presentation. And at the center of EnterpriseWeb's platform is this telecom ontology. It's a harmonized standards-based model. And you can see this is just indicative standards, right? ORAN, 3GPP, LF Camera, Oasis Tasca, Amplify, Etsy NFV, TMF Open APIs, all the usual suspects. And we have this all in a harmonized graph-connected model that we give to customers right out of the box. And it's completely extensible by the customer's own operational models. So the telco can bring its own, whether it's JSON files, RDF, or XML, whatever they have, even Word documents, we'll bring those into the graph as well. So they get the standards-based foundation, and they can extend it with their own operational terms, because obviously every single telco is there might be an 80% overlap, but it's that 20% that's unique to them that is everything that matters. And so we deploy that out of the box and into Snowflake. And that provides a unified network view in standards-based terms that efficiently serves operational context to agents from multi-domain autonomous networking. So what we were presenting with Snowflake in Barcelona was multi-domain, multi-agent coordination. And we're going to do a demo of that today. If you note, I'm in my slides right now, but I think for you, all of you, if you look at the chat, there are three links I provided. One to the press release about our joint solution with Snowflake, another one to a blog that goes into the detail for the use case, and it even has actually some links to demos in there already. And then there's another one, which is a blog post. And they're all related. So for anybody that's interested in what we're discussing today, I suggest that you just click on those links, get them in your browser already. As Graham had noted, this presentation will be recorded and made available to all of you, as well as the PDF of the deck. And we always add extra slides to the end of the deck too, so you have more background. So there'll be more than enough content for everybody. So this is, for those of you who aren't familiar with Snowflake, it's the largest cloud-hosted, data aggregator, data warehouse company in the world, and they run over AWS, and they're cloud neutral, so they run over AWS, Azure, and GCP, and they run all over the world. So it gives you a data platform that is hyperscaler independent, and around their data warehouse, they build a lot of analytics tools, AI tools, and services for working on that data. And of course, they have a lot of telco customers. Notably, AT&T has been public. It's been in the news that AT&T is working with Snowflake, but obviously others as well. And they offer a service called Snowpark Containers, which is just a container service. And Enterprise Web deploys itself into that container service. And this makes us a native app. So we can be running in a customer-specific or telco-specific tenant in Snowflake, in any zone around the world, with any hyperscaler around the world, or across many, and you'd have consistent data and automation services across your hosts, which is actually in and of itself an exciting thing, right? You're having now not only data services that are hyperscaler independent, you'd be having middleware services and an ontology that is hyperscaler independent. So you could actually distribute yourself as you see appropriate, or work with the partners that you see appropriate. So we deploy there. Now, what's pretty cool is that those Snowpark containers are really generally meant for lightweight data apps, like literally a small little app to do a specific function over a specific warehouse, performing certain analytics and AI. That's what it's really intended for. But the Enterprise Web platform, and you can see it's rich. It has the ontology, unified catalog and repo, unified inventory, CMDB, orchestration and management, observability and AI ops. All of that is in 50 megabytes, 50. So we deploy in a set of containers right natively into Snowflake. And instead of just being a data app, you're literally getting a rich system that's ready to use out of the box. And of course, this can be all be sourcing data from the network, from EMSs, from inventory systems, other data aggregators, et cetera, from many sources. Now, Enterprise Web is enabling Agentic. We're exposing through our platform, so through Snowflake into Enterprise Web, we're able to expose telco operations through the Model Context Protocol to enable telco-grade AgenticAI for dynamic and contextual automation with strong governance. We also are enabling, it's through a secure AI gateway. So the agents are all registered with access controls and permissions. So everything, when we say telco-grade, we really mean telco-grade, right? We mean carrier-grade. We mean it's secure, scalable, performant, resilient, all the things that you need, but aren't really present in many early agentic experimentations, right? Many of the early agentic experimentations are proving a functional point, but they're not really proving that they can scale. They're not really proving they can be secured. They're not necessarily proving that they're even accurate. And so that's some real challenges. So enterprise web, it comes at this from a very specifically that, strong governance at scale. In addition to enabling telco-grade agentic AI, we're also enabling a natural language interface. So users can talk to the network and even talk to their agents to design, deploy, and manage services. So essentially exposing our no-code agent studio for declarative design, deployment, and management. And in this case, the agents that we're working with are line graph agents. So they're truly independent of enterprise web. When you use enterprise web to model an agent, register the agent, give it a persona and RBAC and ABAC permissions, you are standing up an independent line graph agent that actually lives outside enterprise web system perimeter. It'll live inside Snowflake. It'll live inside a controlled container under Snowflake governance. But the point I'm trying to make is that it is truly an independent agent. It's not something hard coded to enterprise web. It lives outside enterprise web. We just make it very easy and fast for you to design and deploy agents, as well as to design and deploy services, network services. Now, when going back to that sort of what we're doing that's very distinguished to make things carrier grade is one of the biggest challenges. And I mentioned at MWC, context was the big buzzword of MWC 26 this year. And of course, context is actually a challenge for most people, right? Because, context, if you think about it, it's not just, people are using context in very narrow terms to mean just some related metadata. But if you really think about what context means, right? Context really should be all the relevant out of what they call in computer science, out of band information. In other words, information not shared over the wire, not through the communication. So it's essentially all relevant external information to that specific interaction for that specific user or client, filtered by security, right? And historically, gathering that data, wrangling that data, filtering that data very specifically in a very pointed fashion is both very difficult and also super expensive as a set of operations, right? Because you're doing this in the moment. Your context, the nature of context is it's what is the relevant context now to this specific request from this specific user in this specific location at this specific time, right? So context is very ephemeral. So it has to be processed very efficiently, high speed, thousands of operations per second to contextualize an interaction. And if you think about it, even in this current age of agentic AI and generative AI, two things. We know that generative AI doesn't have consistent and reliable latency and predictable latency. You can have latencies with LLMs that are seconds to, a fraction of a second to 10, 20, 30 seconds. Well, generally that's a problem in a network, right? Also, it's not accurate, it's not secure, it's not scalable, it's not performant, it's got these other things too. But actually, what's the context from the LLM? You're usually like doing something like GraphRag or whatever. You're chunking documents. It's very GraphRag and these other kind of tools around LLMs are very blunt instruments, right? What you'd really context itself should be very precise because we want the agent to do something very specific, and we want to essentially eliminate or control for hallucinations, and we want to optimize the outcome. So context should be something very specific. And so enterprise web is delivering a series of services to these agents that help that. So when you design an agent through enterprise web, it's going to have hooks back into enterprise web. It's going to be a registered agent by default. It's going to have RBAC and ABAC that can never exceed the permissions of the user that created it, right? So a user creates an agent. That agent can't exceed that person's permissions. It's less than their permissions, right? And that agent can have a persona. It can have a scope over a specific domain. It could be limited to doing service management over the RAN or something like that. So you can get very specific on it. And then we're going to serve that agent domain as a service. So just knowledge about that domain, relative information maybe about the standards. And the relationships. Context as a service. We're going to serve it domain, state, and telemetry. Objects as a service. We're going to not just serve it strings, but we're going to serve it things. We're going to serve it rich metadata objects. So when it asks about a service and wants to know about the router, we have all the details, the current state and history of that router, right? Its properties, its behaviors, its constraints, its affinities, its anti-affinities, etc. Really rich knowledge. We're also going to serve tools as a service, not just lightweight tools, but middleware services, communication services, brokering kind of services, integration, transformation, automation, configuration, orchestration services. So these agents can be strongly empowered to do very precise things accurately under governance at scale. And of course, that's all the magic trick to do this, telco-grade. And if you don't have those things, then you really have a challenge, right? You might have a great demo. It might be functionally doing something, fulfilling something. But if you don't have this set of services, including down at the bottom, governance as a service, security, identity, transaction management, state management, logs, and distributed trace, all of these things are handled by Enterprise Web as sort of the intermediary. It's the intermediary between the agents and the data, the human clients and the data, and it's optimizing all of those interactions all of the time. In this demo, so and hopefully that made sense, but I really want you to understand what makes this presentation telco-grade, and you'll see it in the demo. In this demo, we're going to show you how we deployed into Snowflake. We point our ontology at a Snowflake, let's say a telco's data warehouse, their AI data cloud. We introspect that warehouse. We do entity extraction and algorithmic mapping, and we generate a set of standards-based metadata objects for that with zero copy. So we're not copying data. We're just creating metadata objects in Enterprise Web that represent the data in Snowflake. So zero copy. That's also very important for scale, performance, security, all those things like that. We're also going to then, once we see those objects, right, we're going to autofill them with standards-based metadata, and we're going to wrap them with standards-based interfaces, right? So this data becomes now operational, right? We're operationalizing the data inside Snowflake. And then we can generate implementations around interfaces dynamically for the entities and elements represented in that data. We can then wrap the elements. So if there's a service, we can wrap them in TMF Open AIs, expose them through our secure AI gateway via the model context protocol to enable model-based automation. Now here, I know that knowledge about agentic AI and generative AI is not equally distributed. And so sometimes I'm going to dive a little bit deeper for some people who are really getting hands-on with this. One thing that some people might know or are starting to experience is that the model context protocol, while it is a good protocol, there's a lot of debate about it. Some people are actually saying, it's too heavyweight. It loads all the tools all the times. It's a bit clumsy and latency bound. So we're just going to do CLI. And of course, CLI just means it's the wild, wild west. Everything's going to be one-off, manual, and custom integrated. You don't really want either of those things. So when one thing I want to make clear is we're using the model context protocol because it is a standards-based, emerging standards-based protocol that includes governance ideas. And the way we implement it, though, is dynamically and contextually. Enterprise Web doesn't generate static interfaces. We generate interfaces on demand for every interaction at scale. So our interfaces are dynamic and contextual. That's another way we apply security and governance, right? We're only generating the interface for that moment, for that interaction, for that agent, for that service, right? We're going to log it. We're going to trace it. It's all going to be filtered by RBAC, ABAC, right? So, just emphasizing that telco-grade aspects of what you're going to see today. And another nice aspect of this is we're already pushing the envelope with Snowflake is to do this in a distributed manner We call this whole solution a knowledge plane, where the ontology is serving the knowledge, the objects, the context, like I mentioned, up to the agents and the humans, being an intermediary between the agents and human clients and the underlying data. But we can actually do this and represent the telco domains. We understand that most NetOps are not going to happen in the cloud. The actual execution of the NetOps is going to happen in these different, the RAN domain, core domain, transport domain, the infrastructure domain, in the telco cloud, on-prem, in data centers, at the edge. And so the whole solution has to be distributable. So EnterpriseWeb and Snowflake are presenting a solution that can have sort of an end-to-end domain called the slice management domain here, through standards-based interfaces, NSMF, NSSMF, as well as accommodate deploying Enterprise Web, because it's only 50 megabytes. Enterprise Web can deploy down to the RAN, the core, the transport, to the infrastructure, down to base stations, wherever you want to deploy it, and we can create a fabric, right? That's all connected semantically. And these ideas, while this might be the first time you're seeing Enterprise Web, these are the kind of ideas that the 6G architectures are hinting at, right? They need to be event-driven, goal-oriented, semantic, horizontal architectures, right? This is what we're doing, right? This exists today. It supports 4G, 5G, and future forward to 6G architecture. So today's demo use case is going to concretely be a secure 5G gateway. We're going to use Linux Foundation's AetherStack for 5G core, and we're going to use Kamalio's open source IMS. The 5G core is going to be deployed directly by Enterprise Web. We're going to deploy that. And then just to show federation, we're going to use the Ansible playbook to deploy the IMS. We don't necessarily need Ansible because we can do automation directly, but a lot of our telco customers are big Red Hat sites. And we're also close partners with Red Hat, and we're tightly integrated with OpenShift AI and Ansible, so customers can reuse. And in general, Enterprise Web is open for integration and federation with any of your existing vendors, your domain orchestrators, your NAS, et cetera, right? So this actually demo is also going to show an extension. We're going to do an integration with ServiceNow for incident management. So that's a pretty rich use case. Now, the use case is just going to be driving the storyline. What we're really going to today's focus is really on the agentic aspects. So today's demo is going to be broken down into 4 parts. We're going to show you, and this is going to go down pretty fast. And remember, it's going to be recorded, so you don't have to and we're going to share the deck, so you don't have to scramble down to take notes or take screenshots. This will all be made available to you. I also shared those links to some background context in the chat. So if you joined late, please see the links in the chat, and you might want to open those up before the end of the meeting so you can review them after. But we're going to do a zero-copy, no-code integration between Enterprise Web and Snowflake. We're going to show you how easy that can be. We're going to then show you rapid declarative design of LangGraph agents. Then once those agents are deployed, we're going to show you natural language interactions with the agents to talk to the network. And then we're going to show you sort of the closed loop autonomous aspects, where with everything deployed and the agents deployed, how the system is just going to connect the Snowflake's Cortex to LLM and some of Cortex other like semantic views and other services, and how Enterprise Web is going to do sort of the dynamic orchestration of the network service and the AI and the data. That's actually really exciting, right? Because, you really want one holistic approach to connect those things, one holistic approach to security, one holistic approach to governance, one semantic model that connects your agents, your services, and your data, right? That itself is sort of a transformational aspect. You can just imagine what that means for performance, for quality of reasoning, right? Just the ability to reason over the service. Because now, if the agents can, under security and governance, can reason over all the relevant information, they're going to make optimized decisions. They're going to make those decisions much faster, and they're going to do it with full trace, with full logs, etc. So explainability is all there. And yet another thing that's often missing or challenging, let's say, in sort of typical agentic and Gen AI demos. So I'm sorry, it took a little bit of time, but I wanted to give you that setup. My colleague Bill is now going to do the demonstration, and he's going to walk you through those 4 areas. And we can stay a little bit longer on the call for a Q&A. And if you put questions into the chat, if we don't get time to answer all the questions, I think there were some questions that came in even before the meeting, and we would love to actually get interactive with you. But be assured, if we don't get time to do it on the call, we will follow up with everybody individually, and we'll also share our responses to the IWPC team so that they can make our responses available to IWPC members after the call. So Bill, I'm going to stop sharing. Why don't you take it away? All right, Bill.
Okay, that's out of the way. Can you see my screen?
Now I see a slide.
Yeah, perfect. Okay, so as Dave mentioned, I'm going to do the demo in 4 parts. I'm going to start with showing you how we do a zero-copy, no-code integration between EnterpriseWeb and Snowflake. So we start out with EnterpriseWeb deployed in Snowpark containers. We won't go into too much, but it's within the security parameter of Snowflake. But there's no actual connection between the customer inventory, which I'll show you right here, and our EnterpriseWeb solution so far. So right now we're just deployed. We start with some simple data that's sort of aggregated already from a telco. And the example is really at a level of sort of elements and metrics. So if we looked at any of this data, it's relatively flat data.
Well, just to be clear, you're in Snowflake and you're showing the
Yes,
cloud warehouse.
Correct. Yes, I'm inside Snowflake using their database explorer. So I'm showing the inventory that's in Snowflake, so a Telecom inventory. And right now I'm just looking at a table here of basic elements that are being tracked by this aggregator. So you can see it's things at the level of routers, ports, containers, pods, etc. There's nothing here that's really a sort of, how would I say it, like a fully formed kind of telco object. Like there's no services, etc. here. This is really almost the lower level, they call it dimensional semantics, but basically the data points available for containers and other services that have been deployed. And what we're going to do is we're going to right away make a connection to this inventory and show how EnterpriseWeb's Telecom ontology is able to enrich the data here, and then we'll start right from there walking through the rest of the scenarios. So to make a connection between these 2 systems, it's pretty easy. It's like everything else in EnterpriseWeb. What we're going to do is we're going to register a new endpoint. So we're going to walk into one of our modules. It's just used for making connections like the one that we're going to be showing you right now. So I come in as basically an administrator on the EnterpriseWeb platform. There's right now no connections between the 2 systems. So I'm going to create one. This is a model-driven process. It's very easy here, right? This will be my Snowflake inventory. I'm now going to add my admin endpoint and a token file so that I can connect. And what the system's going to do is interrogate the data on the other side of that endpoint. It's going to look at schemas and everything else there. And what you can see is right away, it identifies that this source is an inventory source. You can see there's potential options here. It's a learning system, so it's seen things like this before. It's 100% likely that this is a Snowflake warehouse based on all data, and again, it's rounding, but it could potentially be other sources, and it'll identify where it's pulling the data. Once I confirm that, it goes ahead and actually introspects what's on the other side of that endpoint, and it does the algorithmic mapping, processes over the data that's in there. So the Snowflake tables, etc. It's going to be matching them to elements in our ontology. If you look at it here, you can actually go down to whatever level of detail you might want, but it will pick out those things like the tables that I went into a moment ago, and it will show you exactly how it's mapping it to things within the EnterpriseWeb ontology, including the ability to actually synthesize new object types. In terms of Snowflake, that means actually a bilateral enrichment of the data. So it means actually pushing back tables into Snowflake. And again, that's all permissioned, all those kinds of things, right? They come from the the ontology itself, so the governance aspect of it. But if I'm permissioned, I can write back some state, which I'm going to do now. There's a lot of other detail here, but what I'm going to do is right now, I'm just going to confirm this and push it into EnterpriseWeb, and then we'll take a look at some of the objects that's generated, right? So that whole process, I talked to it it took a while to do that, but it was only a couple of seconds, and I've already got now a connection between the two systems that's zero copy, no code, and everything else. If I go back into Snowflake, what I can see is that if I refresh this, I can see it created the new tables that are related to those higher-level abstractions. It identified, looking at the elements, what functions would be there, what services, etc. And I can go in and take a look at them. And again, this will scale to whatever level of detail you have here in the example. There's only a few services in Snowflake, but if it's thousands, millions, whatever of elements, it's going to handle that no problem. So what I've got here is 3 services that I identified. And again, right from taking what's in our ontology, anything else mapped inside Enterprise Web, and then the data here, doing a match against them, and really just projecting the meaning that we have in our ontology onto this data warehouse. So if I look back in Enterprise Web to sort of complete this, is that if I start using other modules in our platform, there's one called the Network Manager. So a NetOps engineer might want to look at what was in that inventory. They can do that within Enterprise Web, and what they're going to get here is going to be a catalog of all the elements that are actually deployed, right? So it's more like really, it's a network inventory. So you can see some of the elements that were in the database, like the routers and so on. You can see those services that we created over the top. I can literally view this as a network topology, right? I can slice and dice it and see it in any view I might want. I want to see the functions and pods that represents. Walk through them. I can see the ones in red here are having issues, what have you. I mean, I can at a glance see what the data was inside Snowflake, and here it's projected as a graph. I can drill into any one of those elements that we actually created, right? So here's one of the services, right? I don't know which service. Okay, so an IMS, right? It identified vendors, again, based on metadata that it was able to pull out. You can see things like the fact that it's healthy, but this is where the system actually goes and creates the objects that are auto-filled based on standards, standard-based metadata, creates the interfaces around them and so on. And I think Dave had actually laid out that, we're talking about, in this case, some TM forum APIs that we're then going to wrap in MCP. You can actually see that directly here if we look at this network element. You can actually see some of the data here. You can see state and telemetry, and again, whatever's available within that inventory pulled in real time, a life cycle describing where and how it got that data. You can see the interfaces that were actually generated, and it's not just TMF, right? There's some Amplify APIs that might be relevant, but it creates a full implementation around these, right? So I have a fully implemented set of TM Forum APIs, one for service inventory management, one for process flows, what have you, that's applied over this data. And then going that next step, which is when we talked about the fact that we can wrap that TM Forum sort of standard metadata in an MCP interface, you can literally look at it right here. It's sort of a click away, right? I want to view that object the way that an agent might be able to see it. And we haven't gotten to that part. That'll be the next part of the demo when I'll start to actually build some agents. But I can take a look at what the system's able to do right now with sort of just making that simple connection. So if I pop into it, I can actually see the content of the data. So it's in a JSON format that'll be pushed through the tool, what have you. But it's in a TM Forum specification. I'll just zoom in a little bit, so you can take a look at it, a little bit easier to look at. But basically, it's following some TM Forum spec based for the API. It's formatting all the data in that kind of a case, creating things like characteristic data, etc. And it goes down to give you a full story about whatever this service is. A container-based service for IMS, the kind of context an agent actually needs to operate over this, in addition to the kind of low-level details in the TM Forum interface. You see life cycles, and if you were to go on further, you'd start to see things like CDF function, what it means, and again, it will go down to basically all the data you might want in a sort of single interaction with Enterprise Web to power your agent going forward. So that's the TM Forum interface.
Quickly, the power of us, creating those metadata objects with this or standards-based terms and interfaces is that it makes it so much easier to query rich, because an aggregated database by its nature can sometimes be very hard to work with. So what we're doing is we're using the ontology. We're using an ontology is just a model of domain expertise, right? We just happen to have a very rich one with all of these harmonized standards-based one across day 0, day 1, day 2, between layer 7 and layer 1, across domains, clouds, etc. So it's a very rich model that we give you out of the box, but that model is making this information very usable. immediately. So again, it goes to that point of sort of bringing the ontology brings order to the data and makes it operational by giving you implementations on the interfaces. And of course, what Bill just showed here is it means you never have to develop a manual point-to-point interface. I mean, reading the things on LinkedIn or from some of the standards communities where people are struggling doing point-to-point integration, ODA to TMF open APIs to MCP, and it's all static and one-off. And if any element of the solution changes, you're rewriting constantly. That's never going to fly at scale. So the fact that Enterprise Web is generating all your interfaces, we've just eliminated that as a concern. We're going to dynamically contextually generate those interfaces based on policies. And of course, the customer gets to, refine that to their specific operations. But this is the kind of stuff you need to have in place to really get that OpEx efficiency that everybody's looking forward to, right? That's the real driver of Agentic, right? It's not just agents for agents' sake. It's like, how can we do this better? How can we scale our networks? How can we save more money, do more services, be more responsive, have better RCA and MTTR, et cetera. So go ahead, Bill.
So now I'm going to actually transition to the second part of the demo. We did our zero copy, no code integration. What I'm going to do now is show you how I can rapidly and declaratively design a bunch of land graph agents. So I'm going to create a couple of specific agents, right, for domain scope. So I'm going to create a service manager agent that'll take on the persona of one of our modules. I'll speak to that in a second. A second one that'll do application configuration, and then I'll show you how we can make a multi-agent system. And again, I'm going to do it without writing a single line of code. You're going to see me do it completely through a CLI, but there's other interfaces available as well. But what I'm going to do is have a conversation with the system to build that set of agents. So here I am actually in a CLI, already permissioned, everything like that. I'm going to walk through our agent builder and I'm going to have a conversation. I'm going to answer simple questions that will direct me through composing my set of agents. So welcome to the land graph agent generator. And again, we have different targets. I'm going to create a new agent and I'm going to just basically speak to how I answer these questions and what it means, right? So I want to create something new, otherwise I can be modifying. I want to host it in a particular instance of basically our framework, so I can deploy the agents easily. Otherwise I could take them on my own. They're going to be Python land graph code. I can put them anywhere I want. I'm just going to use the server I have. I'm going to name this my service manager agent. And then right away, I'm directed through a whole bunch of patterns here that are going to help the system declaratively to compose, or basically I'm going to specify the intent of what I want this agent to do. I want it to be a worker. And again, there's a ton of patterns here. I want it to take on right away our security model. So again, security first, governance first. This is going to take on my personas for every time the agent works with any endpoint. I want to use, in this case, the Cortex LLM. And again, a selected set here, and I can always onboard new. I want to use our telco domain model, and you could model your own using our ontology, right? So it happens to be telco I care about right now. I'm then saying that this is going to be an agent. So it's just a headless agent that's going to be running within the data cloud. I'm going to assume the identity of our service manager, right? So you're going to get a contextualized MCP server around our components themselves. And to make that a little bit more concrete, you saw me earlier inside our network manager. So for NetOps engineers, I'm going to assume service manager. So let's go ahead and do that. I'm going to, and again, it's already identifying potential endpoints that it might want to use. There can be an MCP server here based on what we did earlier. So let's go ahead and allow that agent to use it. Now I've configured this. Do I want to add any other endpoints? And you say no. And if you slow this down, and there's a lot of detail here in the conversation. It's picking up all the context of what I'm trying to do, including things like the fact that it might be possible to create MCP semantic models in Snowflake based on the connection. So it's exploiting all the available possibilities for the system. And within a second here, so within under a minute, I've already configured and deployed an agent. I've even had it generating a zip file that I can use to deploy this elsewhere, right? So I'm going to go through the process again, create a second agent, and I'm going to go much faster, right? Yes, use the agent. Call this our application config agent. It'll also be a worker. It'll also take on our security model. I'll use Cortex again. Telco domain. In this case, I want to use a different one of our modules for application configuration. It's easy. But now it looks at the available endpoints, right? It sees that there's an Ansible endpoint that's more applicable to things like being able to do an agent config, in this case, to use the Ansible runtime. So we'll permission that. We're going to be happy at this point. Okay, so I've actually created, believe it or not, in those couple of minutes, 2 agents that are now going to be deployed, and I can start to coordinate to do tasks on my behalf. And finally, to finish this off, I'm building a coordination agent, right? So again, a new agent, host it there. So this will be our coordinator. I'm going to, in this case, create a multi-agent system. This is usually something that's pretty hard. You take a lot of manual effort to do it. Well, in this case, I'm going to set up the pattern I want. Again, I want security, but in this case, it's noticing things. This is a coordination agent. Should it actually extend its security model out? Should it defer? Should it hand off my credentials to those lower level or make them, go through a different authentication process? In this case, I'm going to say yes, right? Make life easier. I want to use an agent router. So I'm going to quite literally have the agent here. So I'm going to create this simple coordinator is going to use an LLM. We'll use a micro LLM in this case to fuel it. We'll put it in a certain domain. Sorry, we're sort of setting the tracks for it. Now it's identifying, well, what are the possible agents that I might want to coordinate? I can add new to my collection. I can see ones that are already registered. Just go with all. I also want this thing to have a chat interface over the top. And then finally, getting into a little bit more detail here is that it starts to recognize things like this is going to actually be a multi-agent transit, like it should be a transaction. We'd like to be able to guarantee it. Enterprise Web has middleware services that can do that. So I'm going to add this to the agent, right? So again, this is in contrast to what people do with adding tools from MCP and writing huge descriptions, agents.md files and all those things you hear about. This is me just describing to a system how I want the interaction to work. It'll be dynamic and contextual based on the actual conversation I have. And I've put all those tracks in place here with basically this simple conversation. So my agents are already deployed now, right? So I've got the coordinator agent, I've got the 2 that can work for me. I've basically worked through the entire second point here. So now it's going to just get fun. We're going to have a natural language interaction. I'm basically just going to talk to the network through that agent that we just created. So let's go ahead and do that. So first thing it asks me to do is authenticate. And then right away, I can start talking to the agent, right? So I can actually say right away, I can type trace and actually see what's going on behind the scenes before I do anything else. But let's just see from the beginning. What can you do? And that's a simple question to the agent itself, right? So it goes against the LLM. It tells us that it has information about network services and can order new services and respond to events, right? But how does it know any of this, right? So this is what's great, right? I can actually look behind the scenes at any time, right? I can see a trace. When I logged in, I can see literally what this agent did, right? Which was to log in and authenticate against those 2 other agents, extending your identity. But when I wanted to query what its capabilities were, you can see how it did that. And so on. It's going to go on, for every question I asked, what services are there? And remember, it's invoking, it's taking on the persona of one of the modules in the system. So this was the module. So just to be clear, right, or sorry, the primary module, the service manager, right? So it has access to everything in its catalog as far as things it might want to deploy, and it can see the same inventory, right? So you can actually see that right here, right? Reflected on each side. And I can go, of course, ask more, even deeper questions, right? Tell me more about. It's just exploiting the capabilities of, the combined system, right? The coordinator agent, all the others that it did at any time. Of course, trace, well, where did it go, right? It's through the service manager. So now what I want to do is actually order a new service. So let's go ahead and do that. So there's only the one in the catalog to order. Let's go ahead and use that. Yes, that's what we want. And we'll just pick the top cluster. And just like that, it's put an order through to Enterprise Web to actually do the deployment, right? We can jump inside and see that. And of course, this is all like permissioned, all that kind of good stuff. You can see that the service is being allocated here within another 10 seconds or so. This will actually be stood up and running, right? Okay, healthy already. Okay, good. So we can go ahead and actually look at a trace at whatever lower level. We can see literally, what the system was permissioned, what the interface was that it went through, and for the on the other side of it, there's a full trace of literally everything it went through to deploy this, ordering subnets, and it's all even filterable by the domain itself. So that's great. There's a set of observability frameworks on the back, and of course we can even go in and just make sure, well, as we would expect, right, that this is going to be round trip, right? So what services are there now? Right, so that agent again is going to be aware of, there's our new service, right? We can look at the observability framework that it can put around this, because it's going to be able to do day 2 ops, right? So this is what we're going to show at the last phase of the demo here. But so this is actually being observed. It's all again under monitoring and sort of continuous assurance. So what I'm going to show you now is, for the purposes of the demo, I turned off day 2 operations, right? Otherwise, the system would just recognize a fault if I did something like flood it with, in this case, in a simulated denial of service attack. If I did that, normally what would happen is the system would just recognize and start making fixes, right? But I turned off AI ops on purpose so you can see before and after here. So I'm going to flood this service that we just deployed with simulated traffic, right? So a couple of things you'll notice, 2 things, right? One is that the agent itself is actually starting to respond, right? It's doing RCA, determine there was poor performance, what the problems might have been, observability is configured, but AI ops are not on. It's easy to activate those policies. It will go even further though. You can see everything is, sort of redlining over here in the observability framework. So I'm just going to permission the agent to activate those policies, right? Within almost no time, it's back to performing, as expected. If I go back into the system, I'll see what happened here, which is that MCP, so another interaction with the agent through MCP to activate the closed loop policies. Now I'm going to just jump out really quickly to ServiceNow, right? So this was one of the integrations that's really interesting here, right? Is what if during that time, before I responded to the agent and fixed it, somebody noticed a problem, right? So they went in and reported a ticket of their own, right? So just wait for ServiceNow here to come up, right? So they create an incident. All right, so I'll just get rid of that filter. Okay, so there's a bunch of, obviously this is just ServiceNow ticket management. Someone comes in and creates a new ticket, right? Okay, and it's going to be my IMS isn't working right. Even if it's something as simple as that, right? It searches its own database, and obviously there's nothing in here, but we submit the incident here. And what happens is you can actually notice it's already been closed here, right? It's giving us a report. And why this is the system is actually using that agent interface. We can go into what that is, but it's basically querying, and you can see a whole bunch of details about it. Let's just make this bigger so it's quick and easy. We can see that 58 seconds ago, EnterpriseWeb actually resolved this problem. You can see a full story down here, but basically it identifies that this was the most likely service because there was a problem. Tells us what it was, spike in power and latency, what this fix was, and then it even verifies that it's performing as expected, currently healthy, and closes the ticket, right? So this is a nice integration using all the capabilities of what we provided with, and it's basically for free, just by pointing ServiceNow sort of at our system. So going back in though, I'm at sort of the last phase of this demo. So just to show you, we've already done a little bit of this, but there's event prediction and detection going on. You saw the agent pick up the problem with the policies weren't activated and going and activating them. But this is going even further, right? So if I pop back into the system, I can do a couple of things. I can actually look at the event stream that's being generated. Right? What's actually fixing the service or keeping it optimized as it goes, right? So you can see, and there's going to be events here streaming in pretty much continuously. At a low level, what I can actually see is a description of everything from an event being detected by AI and ML that we sort of programmed as part of that day 2 operations. We can see that we're going down and identifying what the service actually was that had the problem. We're even using things like graph data science capabilities in Snowflake to do actually cluster analysis to figure out, that we predict no downstream effects. And once we make a change, in this case, replacing one of the functions or calculating a new config on it, no downstream impacts. And this is going to be going on, as we mentioned, continuously. You can see the impacts of it.
One thing I wanted to point out is that view you just had there was really showing you the dynamic and contextual orchestration the system was doing across the agents, the data, and the services, right? In one quick view, you're getting a full trace of how interactions are moving through the system and touching all these elements, down to the federated calls to ServiceNow, et cetera, interaction with ServiceNow, et cetera, and down to the lowest level of config that is visible to enterprise web, right? Of course, there could be in a domain sort of oriented solution, we might be interacting with domain orchestrators and we're just passing plans and getting state back. We might not necessarily have all the lowest level detail, because if you're isolating your domains, it might be in there. But so enterprise web is flexible. We'll work with what you have in whatever arrangements. The real goal of enterprise web is to provide that end-to-end global visibility and automation capability, which is where, with governance at scale, which is where most people struggle, right? I think telcos can essentially optimize anything for a domain. You guys have lots of experience optimizing things specifically for a domain, and now are even doing agents within a domain, doing agents with at scale with governance, accuracy, security, resilience, right? All of those things is fundamentally hard, and that's what we're really presenting. Bill, anything else? Are you going to show the semantic service here?
That's going to be the last thing. So just the flip of this, and I think we touched on it a little bit, is that we were talking about initially that we are supplementing or enriching the data in Snowflake. That doesn't stop. You can actually see I clicked on the tables here, but it doesn't stop at that that initial phase, right? We made the connection originally just between the two platforms, but there weren't any agents running. Now that we have agents actually running over the top, what the system did here, and it was one of the questions I actually answered along the way at the beginning, I pointed out a little bit, but when we made that connection to MCP connection with Snowflake, there is an ability to push back what they call a semantic view. So there's something now in Snowflake here. You can see there's a bunch of tables here that are aggregating data. But if we go into what they call the Snowflake analyst, right, which is connected to the Cortex LLM, and this is outside Enterprise Web, we have an agent impact semantic view that was actually created. If you go into the details of it, what you can find out is this is literally annotated descriptions of how the agent's working and what it's doing at sort of every step. None of this was built by hand. It was all just generated by our system. But once it's plugged in here, what it lets you do is things in this playground, like ask questions about what were the power savings for operation by the agent, right? So that you can actually do things like interrogate the agent's operations itself. And if you trace over what it's doing over here on the right, it's even able to use what we provided as a semantic view to generate do text to SQL, right? In a targeted way without anyone training this for the specific queries that were in there. It understands the intent. It can even give you, again, the power savings per operation. So it's able to pull them out. And again, this is just scratching the surface of the kinds of things that we're able to do at sort of all levels across the integration between Snowflake's data cloud and enterprise web in the joint solution. So that covers my demo. I'll turn off my screen so Dave, you can put up the contact slide.
Yep.
And then thank you very much, and we'll answer any questions.
Fantastic. Well, that was a whirlwind, Tom Graham. And so I don't know if there's questions in the pipeline. Oh, thank you, Jane Westover. I appreciate the clapping icon. That was a lot of content, but it's all recorded, and you might want to sort of play it back at your own leisure and at your own speed.
So, Dave, can I just raise a couple of questions that came in as I think you saw them provided before the actual webinar started. So the first one came from T-Mobile, and the questions here: how do you scale AI at GRAN level, GRAN, and what are the challenges for the end-to-end experience, bottlenecks, commercialization, value proposition for a service like this? Is that something you can talk to?
Yeah, absolutely. So, I mean, scale is the fundamental telco question, right? Anybody can do a one-off functional demo. Having all those properties, in particularly scale, is the real critical thing. So Enterprise Web is itself cloud native. The engine of Enterprise Web is serverless. So literally, Enterprise Web is a fully dynamic. It's event-driven, async, concurrent, massively parallel. If you just watch the speed of the demo, if you notice the slowest thing in the whole demo was waiting for ServiceNow to wake up. Right, that was the slowest thing in the whole demo. Otherwise, Bill was clicking through the system and everything was. And remember, think of all the things Enterprise Web is working through. Right, we were going back. We were dynamically orchestrating the LLM Cortex for Snowflake. We were working over their AI data cloud. We were working with those LangGraph agents, which are independent deployments, really, but everything was essentially sub-second. And so we really were designed from the ground up from the scale. Like the name Enterprise Web comes from originally enterprise-grade web scale, right? Those are two things that don't necessarily always come together. To be enterprise-grade means one thing, or carrier-grade means one thing. To be web scale means another. And that's what Enterprise Web really fuses. So the system, it's 50 megabytes, it's deployable, it supports a lot of different deployment strategies. As I mentioned, you could have a distributed knowledge plane where Enterprise Web at 50 megabytes could be deployed at the RAN, the core, down to the infrastructure, could be deployed down on base stations, could be deployed at the customer edge. So that just opens the door to a lot of scenarios. And one other thing I'll mention that sort of touches or gives a hint at sort of the performance and scalability is we benchmarked. So in addition to this great work we do with Snowflake, and hopefully everybody can see how natural the relationship is between the data side, and everybody knows data is critical to AI, and the automation side, how complementary these two solutions or offerings are. So it's a very natural relationship and a very positive one. As I mentioned, Sridhar Rao is the global CTO for Telecom at Snowflake. We're working with him directly, as well as Joe G. Phillip, both great folks over there. But we benchmarked in the Intel labs on Dell Edge servers, on Xeon 4, and we showed how Enterprise Web at scale could optimize AI and network workloads on CPU first, no GPU required. Of course, GPU is a huge barrier to actually doing anything at the edge because of the cost of infrastructure, the short lifespan of GPUs, all of that stuff, the heat and cooling requirements, energy requirements, all that stuff like that make GPU at the edge, let's just say, untenable. And but CPU first, right? It gives you an idea that how high performant our interactions are. Now, there's a lot of technical detail as to how we can do that so efficiently with an LLM. We're not going to get to that on today's call, but we have specific methods for working with agents and data and language models hyper efficiently. It all goes back down to that point, is that Enterprise Web does everything dynamically contextually. So that means we do everything incredibly targeted. Where if you think about stack architectures and siloed stack architectures, every time you build a stack, you're building a very chatty network. That stack itself has a lot of overhead, right? The LLM has a lot of overhead, right? OpenShift AI, those things contribute to overhead. Enterprise Web is, because it's a horizontal architecture, is minimizing the overall overhead and latency of the solution. That's probably the best answer I could give in a minute.
Dave, thanks very much. So listen, we're just about out of time, but there's another question here that came in for, again, another carrier, smaller carrier down in the south, Jana from C-Spire. So what mechanisms are in place to enforce identity policy and auditability for agent-to-agent interactions, particularly in the scenarios where agents may trigger financial transactions or network changes? And do you see Snowflake enabling a shift towards real-time usage-based microtransaction models at the network layer, where telcos can expose APIs for agent-driven services? And if so, how is that being operationalized? Sorry for the long question, Dave.
I'm going to try and see if I can do that.
Which is Jan just put
it's a great series. So let me answer. Thank you, Jana, for the question. And first, Snowflake has the nice thing is Enterprise Web. So we've been really talking about Enterprise Web's governance and all things we're doing. But I forgot to note that Enterprise Web is deployed as a native app inside of Snowflake. So that means we inherit the Snowflake governance on top of that, right? So this is a very layered security. So was that a call? Was that question done submitted pre-webinar?
Yeah, yes, it was. Yes, it was. It came in with the registration.
So hopefully, Jana, you saw that a lot of the governance things that we brought to bear, you saw that right in the demo. Hopefully that answers that as well. And but another aspect of security and governance at scale is the very fact that we're completely event-driven, async, concurrent, massively parallel. It means there's almost no attack surface, right? Everything's dynamic and contextual. There's no long-running threads, right? There's no long-running sessions in Enterprise Web. We're doing state management with durable memory asynchronously in an incredibly cloud-native way. So that itself means that there's just almost no point to sort of get at the system. There's just nothing long-running there. Then the other question as to the security protocols. I mean, ultimately, when we deploy to a customer, it's their preferences ultimately on security protocol. I mean, there's a set of security protocols that most everybody follows, right? There's OWASP, which is sort of a security standards body, and they make strong references on best practices for security. And Enterprise Web pretty much supports all of those. Different telcos or operators have their own separate sub preferences and configurations, and we support that. But we support obviously single sign-on and all of that, Active Directory and Kerberos and HTTP S2, it just goes on and on. But there's a lot of security protocols that are all enabled, and some of those absolutely are customer preference, their choice. It's a configuration /integration with their people tables and anything else that they might be using.
Hey, great, Dave. Thanks very much. And Janet, I'm sure if you want to follow up with Dave afterwards, I'm sure I'll be more than happy to give you a full-blown overview and probably more demos if you have time for that. So we're out of time. Thank you very much, Dave. Thank you very much, Bill. Thanks for everybody for coming on the call. And as we know, lots of people will be taking this on board in different time zones. So looking forward to any feedback. If you've got questions for Dave, you can see his details on the screen here. Otherwise, feel free to contact us and we'll put you in touch. So once again, thanks to everybody for coming on the call. Thanks, guys. Really appreciate it. And look forward to speaking to everybody again soon.
All right. Thanks to everybody. Thanks everybody on the IBC team and to all the attendees.
Thanks, everyone.
Ciao.